Now, indices, okay, actually we have gone through this kind of question, right? X square, x cube, x power 1, etc. Right? So what are all these numbers? For example, let's say x square, you know that x square is just x multiplied by x. And if I have 5 with a little small 4 on top of 5, on the right side of 5 is something called superscript, right? It's a superscript of the number 5. So 4 is a superscript of the number 5. So this superscript is actually, later you know that it is actually called the index, it is called the exponent, or it is called the power. Okay, so when we have 5 written as we have 4 there, it actually just mean 5 times 5 times 5 times 5. So 5 times itself for 4 times. Okay, so this is a shortcut for us to represent a number like this. When we have 5 times 5 times 5 times 5, we are not going to write it so many times, especially when you are doing some. Imagine last time, those mathematicians or scientists, when they want to do some research and so on, they can't be just writing it like, let's say if 20 times, then you got to write the number 20 times. So they use a symbol like this kind, okay? So for example, 3 to the power 6 means you multiply the number 3 6 times, okay? So in general, if we ever come across a number like this, we see a number A with a superscript on the number A. In this case, the superscript is actually the number n, okay? So the n here actually means that the A repeated itself n times, okay? And how do we read it? We read it as A to the power n, A to the power n. Okay, so A to the power n, so this number A is called the base, and the number n is sometimes called index or indices in plural, or power, sometimes it's called exponent. Okay, so this number is the exponent or power or indices, and then this is the base. Okay, so how do we call it? We cannot say n a n a with the superscript. We don't say that. We say the n power of a, the n power of a, or a to the power n. Okay, so this is how we read it. Okay, so why do we need indices? Okay, we need indices when we want to multiply numbers which are big. Okay, so we want to indicate something that has repeated itself many times. Okay, then we use indices. Okay, so you can use calculator and find the value of 7 to the power of 101 times 7 power 99. You will see that the maths error, right? Do you get maths error if you were to use calculator to calculate these numbers, right? Okay, yeah, maybe some of your calculator very powerful, can straight away give you 7 to the power of 200. Okay, but I think most of the calculator, they will just tell you maths error because the number is too big. So when the number is too big, actually if you use the indices way, you actually can still represent it. Okay, wow. Okay, so we use indices to summarize large amount of data. Okay, and then there are some application of indices that we want to tell. For example, if the number very big, then we don't really need to know exactly what's the value, but we want to know how it is related to our previous numbers and so on. Then we can use indices. Okay, so it is very attractive when you are having very little time. For example, imagine if you have 7 to the power of 101. Okay, in the past, people has to write it 101 times for the 7. But if with indices, you just write 7 with a superscript 101. It means the value. So it is useful when you are under time pressure. Okay, so for example, like the next question shown on the PowerPoint, if there are 689,000 Singaporean paid this amount of money in income tax, okay, about four what? Billion, okay, $4 billion in income tax, right? So if this amount were to be changed into 5-cent coins, and each 5-cent coin has a mass of 1.56 gram. So how many of these coins needed and how heavy will the coins weigh? So you can see that actually it started with the number 2.97 times 10 to the power 9. So we're saying that it is useful when the numbers are very huge, especially. Okay, then you will find that the indices, we can just put it into 10 power something, 10 power something. Yes, it's very blur because it's a screenshot of the income tax, so it's not clear. Okay, this one should be clear, right? Okay, this one should be clear, right? Okay, so for example, like this one, 7. Okay, how do you read this? Okay, how will you read this? 7 to the power 11. Okay, or 11 power of 7. But what about B2? Do we also say second power of B? We see when it's something very simple, we just say B squared will do. We don't have to, we don't have to say B to the power 2 or second power of B. So no, okay, so we just read it this way. So the next one, y to the power of x to the power y power n, right? Y power of x, y power of x, sorry, my correction. Okay, y power of x. Then this one, yes, c cube. Okay, so when it's something like square or cube, you just say square or cube. Okay, so what you are going to learn today are these laws. Okay, first one is the multiplication. Second one is the division. The third one is the power law. Okay, power of power. Okay, the power of power. Okay, and then this one is having the same power but base different, and then this one is having the same power, the base different, but this time round is division. Okay, so first one, okay, a power n times a power n will be just a power of n plus n. Okay, for example, this one, easy number, we just use 3 to the power 5 times 3 power 3. So 3 power 5, we write it as 3, then with 3 repeat itself 5 times. Okay, and then the second one is you write 3 repeat itself 3 times. So together, there are 8 of them. So when we write 3 power of 5 plus 3. Okay, and it is actually 3 to the power of 8. Okay, and so, for example, the next one, okay, 7 power 6 times 7 power 2. Okay, so you write the first one 6 times, you write the 7 2 times. So together 6 times and 2 times, so all together there are 8 times. Okay, 8 times. So 7 power 8, yes. Okay, so in general, okay, in general, you can say that, if I have a power m and then another a power n, so the a power m means a, I write it m times. The second one, the a, I write it n times. So if I were to count all of them, I'm going to count m and then plus n. So all together, there are m plus n times. Okay, and so when we write it, we will just write a to the power of m plus n. Okay, so this rule only apply to indices with a common base number. So common base, it must only be common base, then you can do. For example, if you have 3 to the power of 11 times 4 to the power 7, so 3 and 4 of different base, then you cannot simplify. You just have to write 3 power 11 times 4 power 7. You cannot make it to 12 or make it into 3 over 4 or whatever. So it will be just two different indices putting side by side. That's all. Okay, so remember, it must be of the same base. Okay, next one. Okay, the product law. Okay, so, oh sorry, this one is a product law. Just now that one is called product law sometimes. Okay, now next one, example. Okay, example. For example, you have p power 4 Q power 5, P power 3, Q power 6. So you can see that the base only got two different types of base. One of them is P, one of them is Q. So you're going to put the P's together and Q's together, okay, separately, okay. And then when P put together, the first of them has 7, second one has 3, so altogether there are 7 of them. Then the Q, first one you have 5 of them, and next one you have 6 of them, so together you have 11 of them. So when you're actually doing the sum, you don't have to write everything P times P times P times P and P times P times P and then Q times Q, whatever. Okay, so just use very elegant, sophisticated way of doing. So just P to the power of 4 plus 3 and then Q to the power of 5 plus 6. So therefore it's P to the power of 7 and Q to the power 11. Okay? Yeah. For example, the next one. Okay, you actually have came across this before. Okay, so h square k cube, h5 k7. So you know that you got to group them. Okay, same like just now. You group the k, h with the h, k with the k. So the h and h put together, you have 7 of them. The k and k put together, you have 10 of them. So you have h7 and k10. Okay, so this is how you do this one. Okay, next we want to go on to division. Okay, division. When we divide one indices number with another one, so what's going to be? Okay, first thing, again the same thing. It must be of the same base. If they are of different base, you cannot do. So in the way that we write it, we list out everything. We have 3 times 3 times 3 times 3 times 3. Then the other one is 3 times 3 times 3. So altogether there are 5 3's on top on the numerator and then 3 3's at the numerator. So you can do cancellation. Cancellation means you divide by 3, 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 and you're left with 3 by 3. So 3 times 3 is actually 3 square. Okay, so 3 square. So this one is just to tell you how to get it lah. So it's actually 3 to the power of 5 minus 3. Okay, 5 minus 3. You use the caret is only when you do typing, okay, but in mathematics you don't use the is it called the caret sign? Okay, you don't use that. Okay, it's only when you want to type and then there is no maths type, no math software that you can type, then you will use the caret. Okay, next one, 7 power 6 divided by 7 power 2. So that will be 7 power 6 divided by 7 power 2. Again, you divide 7, divide another 7. So now you are left with 4 sevens left. Okay, and 4 sevens written as 7 power 4. But if you are doing a problem like this, indices question, you are not going to list everything out like this. Okay, this one is just to show you why is it that it's 7 to the power 4. Okay, when you are doing the sum, you just do this way. You just say 7 raised to the power of 6 minus 2, which is 7 to the power of 4. Okay, so in general, okay, when you have a to the power m, divide by a power n, that will be equals to the numerator got n times, denominator got n times. So if you were to cancel, all the n times will be cancelled out, and then you are left with m minus n times. Okay, and so you write it as a to the power of m minus n. When you do your calculation, the first 2 steps is not necessary because you have learned indices already. So what you need is just to write this step of a raised to the power of m minus n. Okay, so remember, when you do your sum, no need to go and list everything out. Okay, next one. Okay, this one you have come across. We have done something similar in fraction, in algebraic fractions. Okay, where the numerator denominator has some indices form. Okay, so what you do is you group all the numbers together, you group all the p together, you group all the q's together, and then you simplify and you get your answer of -5 p power 4 q power 2. Okay, so do by very organized way. Put the numbers together, put the same type of letters together. So P with the P, Q with the Q, then you will not be wrong. Okay? So next one, okay, we say that this is the the quotient law. Sometimes this is also called quotient law. It's division now, okay? Quotient law. Take note here, the A cannot be 0. It works for everything except 0. 0 can't work, okay? 0, it will end up not defined because 0 to a power of something, you don't know what exactly is that value. Okay, is it 0 or is it what other number? Okay, next one, power of indices. Power of indices, we now look at power and then another power. So power and power, okay, power of powers if you want to call it, okay, power of power. So here you have 4 squared raised to the power 3, which means it will be 4 squared times 4 squared times 4 squared, which is 4 raised to the power of 2 plus 2 plus 2. Why you get this is actually remember the multiplication, the product law. Okay, so actually your 2 plus 2 plus 2 can be written as 2 times 3. Okay, so this one is actually the first part lah. Okay, so 4 raised to the power of 2 times 3. So when you are doing your sum, the first two steps you don't need to write already. You just write the third step. Okay, you just write the third step and then write the fourth step. That is your answer. Okay, so in general, when you have A raised to the power of m, then raised to another power again. So that means it's indicating that the am, you repeat it n times. Okay, if you repeat it n times, means there are n times of n. Okay, and so this is A to the power of m times n. Okay, maybe the more you learn, the more confused you are, right? Okay, so never mind, this is beginning, so we are very new to it, so you may have some problem with this. Okay, this one, next one, for example, this you came across before, right? So p power 3 then to the power 2, so that means you can say it is p to the power of 3 times 2. And then this one, p power 4, then raised to the power 3 again. So you can say it is p to the power of 4 times 3. So the 4 times 3 is 12. The 3 times 2 is 6. So together, it is 6 plus 12. So you have p power 18. Okay, so don't straight away tell me p power 18. You have to show your step. So at least you must say it is p power 6 times p power 12, which is p power 18. Okay. What if the powers are the same? Okay, what if the powers are the same? So can we say that the power be brought into the bracket? Can we say this? If we have a times b whole thing to the power m, we actually can say it is am times bn. Okay, am times bn, yes. If there's an addition, you cannot. Remember, when you have addition, you cannot write. Then remember the square, the cube, you cannot write. But when it is yes, correct, you can say that. Yeah, okay, factorization. So remember, your factorization there only got power 2, right? So the m is actually 2. So you say a squared times b squared is equals to ab bracket square. A times b bracket square. So this one, it works also, right? Okay, for example, like this one, if you have different base, but the powers are the same, can we simplify into one term? You actually can. So what you do, this is power 3. Okay, so you put power 3, then the base multiply together. So you can say c squared minus d squared to the power of 3. If you want to put it only into one term and not product of two terms, then this is the way. Okay. What about division? Does it work for division also? The answer is yes, it also works for division. So when we have 2/3 to the power of 4, we can actually write it as 2 to the power 4 divided by 3 power 4. You can see the whole expanded form. You see, 2 over 3, 2 over 3, 2 over 3, you multiply it 4 times. So the 2's are all multiplied together to get 2 power 4. The 3's all multiplied together to get 3 power 3. So therefore, this am, so in general, if you have a over b power x is just ax divided by bx. Can go to the what somebody asking? I cannot see already. Sorry, I can't see. Can you type your question again? Because if I go back to question, previous slide, what's wrong? No, I'm not going to upload the slide. Upload the slide, then you are not paying attention. Okay, simplify the next one. Okay, so here, for example, something like this. Okay, so you can see, remember just now the a over b power something. Okay, so each of them you can power. So that means you have 3 square, z power 5 square. Okay, and then y power square. So everyone power square, power square, power square. So this one also all power cube, power cube, power cube. Okay, so here together you get something like this. Okay, so you will get the final answer, this one. Okay, the last step actually no need already. So this one is okay. So these are the rules that you have learned so far. Okay, these are the rules that